For troubleshooting ECM motors in 2004, we developed the Home Comfort Guide. This guide covered how to troubleshoot variable speed motors only because the X13 had not come out yet. So in 2006, when we introduced the X13, we updated that guide and changed its name to the ECM Service Guide. In 2009, we updated that guide again to include both the outdoor fan motor and the new aftermarket Evergreen. So you can get this guide today at our website, thedealertoolbox.com, by downloading the PDF and printing it yourself, or by ordering the guide that you see here. It will help you troubleshoot all of our ECM motors, including the X13. Before we get into troubleshooting the X13 motor, we have to remember that the X13 is a motor inside of an HVAC system. So in troubleshooting any system where the motor may not be running or we're having airflow issues, we have to remember that there's a lot more going on than just the motor. The thermostat has to be giving the proper demand to the system. There could be limits or safeties that are tripped, not allowing the motor to come on. And we could simply have airflow problems. That is the reason for our limits tripping or our coils freezing. And obviously the most common airflow problems are registers closed, dirt load in the system, and your filters, your blower wheel, and your coils. So after we've made sure that none of those are the problem, then we can get to actually troubleshooting the X13 motor. With the X13 motor, as we've already discussed, you will need the manufacturer's manual. Otherwise, you're not going to know which tap is programmed to provide the proper airflow for each demand in the system. The schematic in that manual, which is also sometimes located in the unit itself, will also tell us how the manufacturer has programmed each one of the taps. Some manufacturers will program the lower number taps with lower airflows. Some are going to program them the other way. So we really need to follow those schematics and find out how they've connected them. The voltage on each tap, the tap purpose, and the sequence of operation, all of these things we will need the OEM manual for. When troubleshooting X13 systems, we will need the manufacturer's manual that comes with that appliance. We'll need that for the schematic, the voltage on each one of the taps, the purpose of each one of the taps, heat or cool, and the sequence of operation of the system so that we know when the voltage should come from the manufacturer's control board and go to the motor. There's two different ways that manufacturers are going to run the wires from the control board to the motor. One way we see here, they have a heat and a cool tap on the OEM circuit board, and they've run those two wires over to the X13 motor. But even from this diagram, we can't tell, are all 5 taps on the motor programmed or are just taps 2 and 3 programmed. So this schematic would be necessary to understand that if we want to make speed changes, we'd have to make them at the motor, and to make those changes we'd need to find the chart in the book that tells us what taps are programmed and what their other purposes are. In this example, we see that the manufacturer has wired all of the taps of the X13 motor back to the OEM circuit board. In this case, we would be able to make any of our speed changes right at the circuit board without having to go over to the motor. However, we still, because all we have is a heat tap, a cool tap, and some places for the unused speeds to be parked, we don't know what the unused speeds do, and we would need to find the other chart in the manual that tells what all of the connections on the X13 do. So if the problem with the HVAC system is that the motor is not running, now we can focus on troubleshooting the motor itself, and that's what will be covered in the ECM service guide. Before we can troubleshoot the power going into the motor, we would have to turn the power off to the HVAC system. We don't want to simply take our meter leads and try and push them in through the back of these connectors, because that could damage the connectors and or damage the wires. So we'd want to turn the power off, disconnect our connectors, and check the power that actually meets the motor on the other side. Keep in mind that on the X13 motor, there's 2 inputs required for operation. High voltage for the motor to operate, and low voltage to tell it when to turn on. I like to check the high voltage first because that power has to be on the motor regardless of whether there's a demand call from the thermostat. So I would turn the power off, disconnect my high voltage plug, turn the power on my system back on, and then check the voltage on my high voltage plug. And we can use just about any voltage meter to make this check. You can even use a standard analog meter. So on this plug, we would then identify by wire colors, by wire position, and from our manufacturer's schematic what is L1, what is ground, and what is neutral. We would then check from line 1 to neutral on a 115 volt system and confirm that we have 115 volts. If we do not have 115 volts, we would have to follow these wires back to the manufacturer's control board and find out where we lost that power. So really, that is going to be the same check no matter what voltage the motor operates at. If it's a 230 volt or a 460 volt motor, we're still going to make the same check. We're still going to have our meter leads on the black L1, and in most cases the white, where on this manufacturer they used yellow for the N or neutral position. So regardless of the voltage, our meter leads are going to stay in the same place. If we have the voltage on our plug that we should have from our system, then we can move on. If we do not have that voltage, we need to find out where that was lost, fix that problem before we can move on so that the motor has proper high voltage. So once we've confirmed that we are solved that we have high voltage on this plug, we would then turn the power off again, and now we can troubleshoot the low voltage plug. So again, power is still off, so we're disconnecting the low voltage plug. If the manufacturer did not use a high voltage plug, they used flying leads on that portion, I could just take the common wire out. So what I'm going to do is I'm going to be taking my meter and checking from the common in the high voltage plug and the 24 volts that will be coming to pins 1 through 5. And now again, I need to turn the power back onto my system, give my thermostat a call for heat or cool, and wait for the circuit board timing to send that voltage down to the heat or cool wire. And if that 24 volts shows up, then I know I've got the proper input to the motor to tell it to turn on from that thermostat demand, whether it be heat or cool. So if I've confirmed that that tap is a programmed tap in the motor, and that I read 24 volts between that wire and common, that means that I have the voltage I need going to the motor to tell it to turn on. I've already confirmed that I have high voltage going to the motor, so from this final check, I now know the motor has the voltage it needs to operate, and it's getting the communication it should have to tell it when to turn on. If the motor is not running at this point, it's a failed motor. So to summarize troubleshooting the X13 motor, there's really just two inputs to the motor: high voltage and low voltage. The high voltage power is always on the motor whether there's a thermostat demand call or not. You can check that power anytime. The low voltage will only show up when there's a thermostat demand and the OEM circuit board has timed out any delays that might be in the board. So to check the low voltage, we will need to give a thermostat demand, wait for that demand to time out, and then check the low voltage at the motor. If the manufacturer uses a low voltage and a high voltage plug at the motor, we will have to have both plugs out to check our low voltage to our common pin, which is in our upper plug. But I think as you can see, this motor is really pretty easy to troubleshoot. And if you don't remember any of this, it's all in the ECM service guide. Now another thing to keep in mind is, what if I have a problem where the motor is actually running? In other words, I'm tripping the limit or freezing the coil. Well, those are typically airflow issues. Now an airflow issue that could be related to the motor would be I'm in tap 2 and I need to be in tap 3. In other words, I'm not in the right position I need to be in for the airflow that the manufacturer wants. In that case, I would need the OEM manual to tell me what position the wire should be in to get the proper airflow in the system. However, we could also have problems such as dirty filters, dirty coils, and keep in mind that even though a constant torque motor can help airflow problems, it's not a solution to airflow problems. It's not going to overcompensate for an extremely dirty filter, an extremely dirty evaporator coil, undersized ductwork, or closed registers and grills. If the X13 motor needs to be replaced, keep in mind that the X13, unlike variable speed, is a one-piece motor. Even though it is an ECM motor, it does have a control inside this motor shell. The X13 can only be replaced as one part. So if the motor's failed, you will get one whole motor and control assembly from the manufacturer. And you will have to go to the manufacturer of that appliance and get the X13 motor that goes not only in that manufacturer, but that model and that size system. There's really only a couple of things to remember about X13 when replacing it. One of them has to do with where the motor is in its mount. The motor has a control in this part of the shell. So what you'll see is there's little dimples on the motor, and we want the motor bracket to be mounted towards the shaft from those little dimples. You can see that in this picture here. So basically the only special criteria for mounting the motor is that the motor be mounted towards the shaft from the little dimples that are in the motor shell, so that we don't clamp the belly band mount over where the control area is in the motor. Just like any motors, we want to make sure that when we replace a motor that we center the blower wheel, we tighten the hub nut on the wheel on the flat part of the shaft, and like all of our ECM motors, we want to make sure that when this blower section is going to go back into the HVAC system, that this motor and these connectors be facing in the down position, or at least between the 4 and 8 o'clock position. So if this was the way this blower section was going back in, it would be incorrect. We'd need to turn the motor 180 degrees. If this were going into a downflow furnace, then it would be perfect, because this blower section would be turned completely upside down and the connectors would be facing down. And then of course we also want to make a drip loop out of our motor harness so that no water can drain off of the wires and run right down into the connections themselves. So after we've diagnosed the motor and replaced the motor, the last thing that I also like to make sure is that I don't leave a system that could potentially fail another motor. In other words, are there some obvious things I can see that cause this motor to fail, like water damage and airflow problems? If I find either of these situations in the appliance, I want to make sure and solve those problems so that the customer doesn't have a future failure of the motor. Remember that all of this troubleshooting that we just talked about on the X13 motor can be found in the ECM service guide, including an identification chart to help you identify X13 motors from our other ECM motor products. You know, when you're finishing any service call, it's a good idea to check all of your wiring, to run the system in all modes of operation, check your safeties, and basically do a quick check of the system that's not going to cause you a return visit. Check your drain traps, your drain lines, set your thermostat back where the customer wants it, and of course recommend annual maintenance. Keep in mind that today most customers probably don't know that you can provide annual maintenance and help keep their filters clean, which is going to keep the system running at better capacity, better efficiency, and provide more comfort to the home. Remember, you're a home comfort specialist.